Second part of 3.4 is really pretty straightforward and pretty simple. Biggest thing here is we're really just taking one single part of your quadratic formula. So remember yesterday we talked about the quadratic formula being negative b or opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So today we're only going to use part of it. We're going to use the part that's underneath the radical. So the part that's underneath the radical here, okay, the b squared minus 4a, that's what's called the discriminant. That's going to tell you what type of answer you're going to have or solutions and what to look for. Okay, especially whenever we get into like the graphing and the things like that. I'm sorry to bore you. I'll try to be more entertaining next time. So if the discriminant is positive, okay. So if the discriminant is positive, then you will have two real solutions. You're really going to have one of three things. Okay? You're either going to have two solutions, but they're either going to be imaginary or real, or you're going to have one solution. So what it means to be a real solution is that whenever we get into the graphing side of it, that there's going to be two different spots that my quadratic hits the x-axis. Okay, so that's what we're basically going to be getting to, like here and there. Okay, the same thing can happen if it is a negative quadratic and it looks even something like this here. Okay, it has two different places where it hits the x-axis. So then your next one is when the discriminant is 0. So when everything cancels out underneath the radical and you don't have anything underneath the square root, then you're going to end up with one solution. What that'll look like is something along the lines of where it's going to make the turn on the x-axis. Okay, same way it could be negative, it could look something like that there. So whenever you have one solution, that means that it's going to fall directly on the x-axis and it's going to turn and make the U-turn right there. The last one then is whenever it is, if we've discriminant, two real solutions is positive, one real solution is 0, what do you think is going to be imaginary? Negative. Okay? So if your discriminant or the number that's inside the radical is negative, then it's going to have two imaginary solutions. So whenever we deal with imaginary solutions, what that means is you still have a graph. Okay, you still have a quadratic. You know that because you have that function. But you don't actually have real solutions, which means that it's going to look something like this. Okay? Or it may even look something like that there. It can cross the x, or it can cross the y-axis, but it's not going to cross the x-axis. Okay? So if it's pointing up, or if it's pointing in a positive direction and it's above the x-axis, it's going to be imaginary, or it's going to have an imaginary solution, rather. If it's pointing negatively and below the x-axis, then it's going to also have imaginary solutions. So we're still going to set this up the same way. I still need to have everything over to one side. So I'm still going to list my values of A, B, and C. So I'm still going to list A is 9, B is 6, and C is 1. So instead of using the whole quadratic formula, I'm not trying to solve it. I'm just trying to see what kind of solutions am I going to have. Okay, am I going to have two real? Am I going to have one real? Or am I going to have two imaginary? So what I'm going to do is just take the b squared minus 4ac. So what's b squared? Well, it's 6. I'm going to take 6 squared minus 4 times 9 times 1. Just like I did before, I'm going to group the negative or that minus with the 4, and I'm going to take negative 4 times positive 9 times positive 1. And so I'm going to have 36 minus 36. What is 36 minus 36? 0. So my discriminant, so whenever it asks what's the discriminant, the discriminant is 0. The number that's inside that radical is 0. So what types of solutions am I going to have? One real solution. Okay. Now, I'll be perfectly honest with you. One real is, to be honest with you, what will happen when somebody gets 0, they're going to put 0 real solutions. Okay? Why? Because they get 0. Okay? So, whenever you have a 0 as your discriminant, what is a 0? What letter does a 0 look like? An O. What does 1 start with? O. Very good. Okay? So, 0 as far as my answer. Okay? I never want to have 0 as a type of solution. I'm either going to have 1 or 2. So, either 1 real or 2 solutions, but it just depends on if they're 2 real or 2 imaginary. Okay? I don't want to talk about 0 of something. Okay? So whenever we talk about the types of solutions, it's going to be 1 or 2. It's just a matter of whenever you get an answer of 2, what type is it? Is it 2 real or 2 imaginary? Okay? So go ahead and get out of the thought of, I'm going to say 0. 0 is not an option. 0 is a numerical answer we can get, but 0 solutions is not an option. Okay? So even on 2, I'm going to treat everything the same way. So I have A is 9, B is 6, C is negative 4. I'm going to use the same part. So I'm going to go B squared. So I'm going to hit 6 squared minus 4 times 9 times negative 4. Again, just like we talked yesterday, just like we talked about 2 minutes ago. The negative is going to go with the 4. So it's going to be negative 4 times 9 times negative 4 again. So 36 plus 144. Right? Negative 4, positive 9, negative 4 is going to multiply together to get me 144. Yeah. Add 144 and 36. So my discriminant is 180. So it's positive. So what types of solutions am I going to have? 2 real.
Do we have to find those solutions?
Nope, not. We find the solutions when we actually use the quadratic formula. But as far as the discriminant is concerned, no. You just have to say what types of solutions are they, and then you go from there. We could if we wanted to, but that's not what we're doing with the discriminant. We're just trying to figure out what types are we going to have. Same way then on 3, I'm still going to use A is 9, B is 6, and C is 5. So 6 squared minus 4 times 9 times 5. Again, right there, include that negative. So 36 minus what are we at? Minus 180, I believe. So 36 minus 180. So I'm going to end up with a discriminant of negative 144. So since that is negative, 2 imaginary solutions.